Hi, I'm James Powell from Monster City Studios in Fresno, California, and I want to share with you how we use Formlabs Form 3 to speed up a prototyping or a fabrication process that normally would take a really long time. With 3D printing and 3D design right now, 3D designers are so used to creating um, almost impossible to build sculptures, as you see here on the screen, uh, that they're fine when you print them in a small scale space. But when you try to print those sculptures in a large scale piece that's bigger than any 3D printers out there, I'm talking maybe 5 feet tall, 10 feet tall, all of a sudden it gets nearly impossible to replicate these pieces that are made for really for 3D printers. So we had a client. His name is LC, and he's out of Paris, France. He's a very well-known artist. He calls it calligraphy, and he writes Arabic letters, and he turns those into 3D sculptures, or at least has just started to. One of his most famous sculptures is in Dubai, at the Dubai Opera House, out below the Burj Khalifa. And you can see that here. This particular sculpture had a budget of over $2 million, and the fabricators had 2 years to create that. Well, he came to us and said, "Hey, I have a show at the Wynwood Walls in Miami for the Miami Basel show, and that's one of the biggest art shows in the world. And he wanted to replicate a similar type of sculpture in less than a month, and for about 1% of the budget they had in Dubai. Of course, me being one for a challenge, we said we'd try it. The problem is this type of sculpture is so complicated that once a sculptor gets it, they have a very hard time of trying to figure out how to interlock pieces. So what we did was we made a practical model with the Form 3, and you can see here on the screen the practical model that we made. It's just a little handheld model, and it seems so simple. You're going to have a little model of something you're going to make big. But nowadays, everything we're doing is digital. So usually a sculptor will have to go to a computer, or they'll have to go to an iPad or a tablet to look and to get their reference material. We 3D printed this piece that really can only be 3D printed, and they were able to have that in their hand, and they could work in a 3D space while building the actual structure, because some of these connections are so complex that even if they got into a digital space, they'd have to look in, look underneath. It's really hard to do, but with this 3D practical model, they could do it pretty easily. And it actually created a very successful sculpt. Most of their sculptures they do them over in China, but they wanted to do this one domestically. And you can see here in the pictures, it's very complex, but just by using that one print, the Formlabs printer, Form 3 printer, almost paid for itself. And definitely by doing 2 projects like this, it would certainly pay for the printer. And we've been able to use it to improve our workflow multiple times over. So it's just been an absolute joy having these printers. The quality is so good, and it really allows us to really speed up our production. We were also able to earlier in the year, our company, which we generally work in the entertainment industry, we were able to switch from doing entertainment, because we were shut down, to making face shields and face masks. We were able to use the form printers in conjunction with Formlabs to literally print 3D hard molds, the actual production mold we printed with the printers. So we were able to make rubber silicone masks. And you can see up in the upper left-hand corner here, we made basically, you would say, a poor man's injection molding machine. And we injection molded silicone masks. These masks were designed by Formlabs representative and ZBrush artist Eamon Akhtar. And we were able to produce those on a large quantity by using the Formlabs printers. So they've also helped greatly with that. In the future, we are really interested in printing rubber molds, or at least softer molds, so we can print or so we can cast resin to actually help streamline even more our production process. So that'll be really, really interesting. And hopefully with the Form 3L, we'll be able to print some large molds and cast some really large pieces. So we're really excited, and we look forward to the future and using more Formlabs products. So once again, I'm James Powell from Monster City Studios in Fresno, California. Visit our website if you want to check out more of what we do here at Monster City. A lot of entertainment-based things. Also, we do large-scale play structures and fine art sculptures. So check us out, monstercitystudios.com. And thanks for watching.
Hey everyone, I'm Christina. I'm the co-founder and CEO of Makelab, and we are a B2B on-demand additive manufacturing service that helps businesses prototype, complete low-volume production runs, or create custom models. So dating it all the way back to the start of Makelab, my co-founder and fiance, Manny, and I, we started this business out of an acquisition of a friend's company. We started out as customers of 3D Uniprints and became their top customer in 2016. They valued service, and that's what kept us around. We're both industrial designers from Pratt and always had this love for iterative design thinking and just really making things and really thinking and designing in 3D. And so this love of creative problem solving through design and making really became the DNA of Makelab. So as a lot of you probably already know, 3D printing helps a wide variety of industries with prototyping and product development, visual models, and low volume production. It speeds up the prototyping and product development cycles tremendously. One client of ours told me at a holiday party actually that we helped him shave 8 weeks off of his development cycle. And so because of that, they launched so much earlier than planned. So basically, 3D printing visual models eliminates the need to hand carve foam or wood to make a looks-like model. You can now just digitally model this in your program of choice, be it Onshape, Fusion 360, SolidWorks, or ZBrush, or really any modeling program, and then 3D print it and then paint it. It's that easy. Pictured here is blue foam. If you if you majored in industrial design at all, you're probably very familiar with this. Also, there's a shameless plug. There's a really funny Instagram account called Blue Foam Dust that you all should check out. So also for quantities of 10,000 or less, you no longer have to open up a mold. This photo, of course, was taken from back in the day when colored spinner parties were a thing. Yes, this was a business, and yes, it was run by, I think, a 14-year-old. Power to them. So we work with some really fun clients, and the best part is that they come back to us time and time again, and we develop relationships with them. We get on a casual, know their name basis and really end up rooting for them, their businesses and their projects. You'll see some familiar names here, but basically the common thread amongst all of these like various companies in various industries is that 3D printing saves them time, so they don't have to rush the creative process in order to make time for working with traditional manufacturing methods for prototyping. We can 3D print right away, and we can also 3D model. So everything was going really great, and we had just wrapped up 2019 with 3x growth, and it was amazing. Then COVID hit. And as a way to stay alive, we pivoted very quickly and began producing PPE for the NYC community. We did face shields, mask fitters, ear savers, and custom mask fitters. Luckily, we were able to supplement our lost regular income with PPE revenue, and I got to work with a really cool fitness brand out west. And there's a location out east called Dog Pound. And that connection actually happened through an old friend of mine from high school, which was very fun. Since then, the demand has lessened, and we're still here and we're still alive. It was a stopgap. 3D printing was a stopgap solution for PPE, but it was also for us in terms just to stay alive. It honestly felt like my entire entrepreneurial career has been one big case study about 3D printing and its usefulness as a B2B tool, not just 3D printing for your kids, which is the common connotation around 3D printing. But thankfully, after 2020, like I'm honestly wondering what this industry can't handle. And I'm so thankful that I found 3D printing early in my career.
Okay, good afternoon, everyone. My name is David Finlay, and I am a lecturer at City of Glasgow College in Scotland, and I head up the technological side of the Jewellery Arts and Technology course there. I'm going to talk to you guys today about the integration of Formlabs SLA printing technology within the curriculum that we deliver, and how this has met the technological and educational demands of our students. On the jewellery making course, we cover both the traditional hand manufacturing techniques and also embrace newer modern approaches in jewellery manufacturing, from CAD to 3D printing. Some of those educational units that we've integrated and utilised these approaches are, for example, CAD prototyping and lost wax casting modules. We face a number of challenges teaching this technology in our curriculum, and things like time restraints on delivery, keeping our learners engaged and interested in the subject, to just finding a reliable printing solution, all really to help our students stay up to date with the manufacturing trends used in the industry, but also to learn about the digital tools that are now being used to creatively manufacture jewellery. The integration of 3D printing in our curriculum was introduced about 6 or 7 years ago. However, we only invested in a Formlabs Form 2 printer about 2 years ago now, at a point when we were looking for a more sustainable solution to printing in-house and embedding more prototyping and CAD modules into the curriculum. This came at a difficult period after running a very high maintenance and very expensive printer that was taking up lots of time of both the teaching staff and the technician staff on a daily basis. High fail rates were discouraging and frustrating to the students, and they were beginning to lose interest in the kind of CAD CAM subject area. However, since working with Formlabs equipment, we have streamlined and simplified that process, and the students have benefited hugely from the ease of use, the lack of maintenance required, and the success rates of printing more or less every time. Failed attempts now usually come from student error. But on that note, as we are teaching students who have no previous knowledge of computer-aided manufacturing processes and are learning these technologies for the first time, Formlabs printers have really been an engaging and valuable learning tool, allowing our students to quickly address mistakes and rectify these in the prototyping stage of making their designs. The user-friendliness of Formlabs equipment has also made teaching the technology itself easier for the teaching staff. We find the lack of frustration using the technology has engaged our learners more, and the more that they put in and the more that they embrace making mistakes, the more that they get out of the whole manufacturing and learning process in the end. Just to add as well, the Preform software has also been a wonderful tool for our students who, again, being new to this technology, do not often understand the support structure process. But this software has helped our students to quickly build supports automatically, to get quick results, or to study these supports and understand where they're required as they begin to consider this process for their own models and their own design concepts. So onto materials then. The materials that we print with, well, our students would normally start with a sort of cheaper draft resin and printing that to test functionality and scale of the work. Any mistakes can then be rectified at this point before reprinting in either a high temperature resin, which we use for teaching silicon rubber molds for batch production processes, or in castable wax resin, which can then be taken directly to the investment casting stage and cast in precious metal. The Formlabs castable wax resin has really been an invaluable material for us to be able to cast models in-house in the college. This castable resin burns out cleanly and it delivers high quality results for us. This process didn't take too long to kind of get our heads around. Just some tweaking of burnout cycles, following Formlabs recommendations on things like investment powder, etc. And here in this slide, you can see some of the casting quality of the results of some of that work of the students. So just to conclude then, since adopting Formlabs printers in our department, we have been able to enhance our students' learning of this modern jewellery manufacturing technology, converting what was a rather frustrating module into an enjoyable learning experience of what is such an important manufacturing skill of the future within our industry. So thank you for listening. It was great to share what we do with you. I'll be around to answer any questions that you may have afterwards. Thank you.
My name is Edmund Keefe. I'm a senior lecturer at Manchester Metropolitan University, and I teach in a digital manufacturing facility known as Print City. I'm going to give a brief talk about 3D printing in education. 5 years ago, I was tasked with setting up a 3D print facility at the university. I didn't want to go down the usual route of installing a few extrusion printers in the engineering department and hoping that they'd be used. I was passionate about establishing a multidisciplinary facility that had the best equipment and could meet the needs of the wider community. Two keystones form the basis of what has become Print City. One was software, the other was hardware. Fusion 360 by Autodesk was the software chosen to create the digital content, and Formlabs Form 2 printers were used to make that content manifest. The Form 2 offered the best solution for meeting the needs of jewellery makers, artists, designers, medical professionals, and many, many more across the university. Under the academic lead of Professor Craig Banks, Print City has grown into a crucial Industry 4 centre at the heart of the university. We now have a number of Form 2, Form 3 and 3L printers, which expands our capabilities. I've selected two case studies to illustrate some of the benefits of SLA. First off is an award that we were asked to make for a double marathon, a run from Manchester to Blackpool, which is based on the north west coast of England. And it has a famous ballroom with a tower similar to the Eiffel Tower, which is where the race was going to, the run was going to end. So the only way to really model this tower, based on the original architectural drawings, was we use Fusion for this, and then to produce the delicate structures needed for the award. Form 2 was the only printer available to us for this, really. So some of the benefits of SLA: we were able to stack 9 towers in the build chamber at once. No support was necessary, and almost no post-processing. Straight off the printer into the form cure, and then out and onto the award. The awards were very well received. The other one, again, very quick workflow here. And the other thing I would like to talk about is the work we do with some of the artists that come into the facility as well. So Professor Keith Brown is a world famous artist. He's a sculptor who stopped working traditionally about 20 years ago, and has been a kind of a pioneer in the digital sculpture arena. This is a sculpture he was commissioned to do by Manchester City Council, and it's gone into a time capsule outside the town hall in Manchester. This piece was based on intersections, the crossover of the city, and also very organic and very smooth forms were designed and made. So again, the Form 2 gave us the capability of producing this part with very little support, very little post-processing, and beautiful organic shapes. Thank you for this quick talk, and for the opportunity to talk about Print City. These are just a few of the people we work with, and if you'd like to know more, please visit printcity@mmu.ac.uk. Thank you.
Hi everyone, my name is Michael Kononsky, and I'm the co-founder of PLAATO Technologies. We're a company that makes IoT solutions for the brewing industry. And today I'm going to tell you about how we developed and sold new products in the middle of the COVID-19 crisis. So COVID-19 caught us all by surprise, and the brewing industry is nothing different. There is a growing need to know what is going on in fermentations, what is going on with the beer and cider making processes to make a good product. Nowadays, when restaurants are closed, staffs are reduced, and lockdowns are introduced, it's much more important to make every liter of beer right and save as much money and resources possibly to do that. And we decided to help that industry by introducing a new product that will give you all the necessary data you want to know without leaving your home. So what is PLAATO Industrial? It's basically an add-on that connects to every fermenter ever created and transforms it directly into a smart one. By adding this on the fermenter, it will allow you to know everything about the fermentation activity, how the gravity changes, temperature, batch history, and even detect anomalies along the way. That is allowing you to control one or few fermenters or a whole hive of fermenters without leaving your home. Monitoring fermentation processes is extremely important because that is the single most important parameter of the final product. Controlling fermentation means that you can figure out how to make the best product out there. And we wanted to create a digital twin to that biological process. We wanted to digitalize all that information, a simple graphical way that you can see it from every point in the world. If you're a brewer or that sits at home, or you're one of the production workers on the production floor. We decided to use rapid prototyping and rapid manufacturing. We embraced 3D printing as part of our mass production. We used 3D printed parts and sold this to our clients, and that allowed us to be very fast, to reduce the time between the feedback loops and answer every customer's demand. We have now products in over 20 or so breweries around the world that are in 3 different continents, which use 6 different industry standards. 3D printing and rapid prototyping manufacturing allowed us to overcome all these challenges. And we were able to ship every customer the unit he needs that fits his special setup, because some of the fermenters are 2 years old and some of them are 50 and 60 years old. And we managed to fit them all and make them all smart. I would like to share with you one of our showcases. It's a small brewery in Oslo that used 2 of our units, and 7 more are on the way. And they figure out that they managed to change the way they work by having this digital transformation, that they understand the activity in any given point without even being in the brewery. That's extremely helpful when you are in lockdown or you're quarantined or you want to reduce staff to the necessary. You can follow up all the data by only following your phone or computer. We even managed to save a batch that's been used with some sort of a bad yeast, and we could detect that anomaly days in advance and save a small local business a lot of wasted beer and wasted money, and keep them up and running better, in a better position in these difficult times. And we are now proceeding to different countries. We have more pilot customers in Africa with extremely different standards and fermenters, in Central America and North America now. And we're very excited to move forward, and we will adopt these manufacturing ways at least until this is over.
My name's Paul Thorpe. I've managed Universal DB Production Laboratory for over 20 years now. We have used digital technology in the lab for quite a few years, 5 or 6 years, maybe a little bit longer, but not to a great extent. But over the last few months, I've realized how important digital technology is to audiology. As a laboratory that produces custom hearing products, we always rely on an impression, a good quality impression, to ensure a good quality mold, a good quality product for the person that's going to be wearing them. We make custom-made products which are essentially hearing protectors, water protectors, but essentially ear molds for hearing aids. We make an awful lot of ear molds for hearing aids, something that somebody cannot wear the hearing aid without this custom mold. The materials we've used over the years, all sorts of materials. Some of them are quite labor intensive to make and quite time consuming to produce these molds. But we also rely on the experience and the skills of our workforce, probably the most important thing we've got. That's why a few months ago, when COVID hit us hard, as it did with everybody, we had to drastically reduce the number of staff in our laboratory from around 25 members to 4 members. At this point, a decision was made that the only way we could carry on producing the goods we did was to change everything to digital production, just so our small team can carry on producing the products that are going to be needed for the patients. Just to make sure we had the capacity, we ordered another 2 Form 3 printers because we didn't know what to expect. What we did find was that the majority of the orders that came through were orders for very young children, babies, and vulnerable people. People who just could not possibly lose their hearing for any length of time without causing great distress and problems and stress. We deal with a lot of NHS hospitals, hospital departments that deal with children and newborn screening. So people could be screened and ear molds could be required for young babies as young as weeks or days old, the first days and weeks of their lives. So we use the techniques of producing casts to make the little small soft shells for the babies. And thanks to Formlabs introducing us to the biomed material, we were able to produce high quality biocompatible hard molds for these people as well. Another very important aspect to this procedure as well was the scanning, the ability to scan the impressions and keep them on file for the future. And sure enough, an awful lot of patients weren't able to get successive impressions done. So we had to rely on the impressions we had on file, and we were able to increase and offset these impressions to allow for growth of a baby or a young toddler. And also people that had broken molds, some molds that were in pieces arrived, and we would put them back together, scan them, and from that we could make a brand new mold for that patient so they could carry on hearing and using their hearing aid. Clearly, there was an awful lot of gratitude from the hospitals and the patients alike, along with parents who'd taken the trouble to write into us and thank us to allow their child to be able to wear his hearing aid over this difficult period. I think I've learned that digital technology's got a massive part to play in audiology, both now and in the future. This technology can only grow and improve, but it has allowed us to provide our customers with the service that they've needed over the last few months. Thank you for listening.
Hello, my name is Vitaly Pantsulaya. I'm from Russia. I'm dentist and maxillofacial surgeon. I'm working already 13 years in dentistry field, and today I would like to talk about how 3D printing technology changed our everyday workflow. Dentistry impacted much of new 3D printing technology, and my practice impacted as well. Before, we were in stone age of dentistry, where we had done many things manually, but today our 3D printers can create temporary crowns, dental models, and it helps our patients much. As a surgeon, I meet many patients every day with cranial and facial problems, and now we can connect with other specialists in diagnostic field with sending 3D printed models, STL files to determine pathology in skull and facial bones. We can print a real size skull cranium with all internal bones, teeth and jaws, for example, to observe anomalies and put right diagnosis. We can help my patients with temporomandibular joint problems by making 3D printed bite splints so it relieve pain, as you can see in this real case. After that, we can finish their prosthetic rehabilitation. Planning our surgery, for example, dental implantology procedures and bone augmentation techniques like jaw splitting and sinus lift through the 3D printing guides, made our operations safe, predictable, and minimally invasive. Here you can see the real case of jaw reconstruction with precise planning, and finally, patient can have ability for oral rehabilitation. 3D printing also provides a lot of benefits in prosthodontic field, and we can deliver provisional and long-term prostheses more fast and even without traditional silicone impressions. We can make immediate loading after implantation so patient can eat and communicate with other people with their teeth. It also changed my dental technician's everyday practice, and you can see how precise and fast nowadays a production of such crowns. Even in COVID period, we can use 3D printing technologies as individual respiratory protection. I made this like an experiment with my face cam and make it individual to my face, so it protects me from infection. And then I can say that I hope that soon it will be available more biodegradable polymers for bone and soft tissues, scaffolds, and cells in bioengineering field. And I can proudly say that 3D printing is life-changing technology. Thank you for your attention.
Hello, Formlabs User Summit. My name is Meghan McCarthy, and I am program lead for 3D printing and biovisualization at the National Institute of Allergy and Infectious Diseases. And today I'm just going to give you a little introduction to some of the ways that we use 3D printing at NIAID. So we started with binder jet printers back in 2007 because we found them really valuable to be able to show our investigators things that they wouldn't be able to see otherwise on a 2D screen. So being able that experience, this tangible experience of holding something in your hand, we saw that there was something to gain from that for research and discovery purposes, and just for communicating concepts around that. So following on from that, in 2014, we launched the NIH 3D Print Exchange, which is a free resource that we have where users can go and upload and download 3D printable models for specifically for bioscientific and medical applications. So this includes molecular models, anatomical models, and even open hardware that could be used in a laboratory, or say like in some kind of any kind of a research or a clinical setting. So we have used SLA printing because it allows us to sort of combine what we would get from binder jet printing in not having supports, to being able to have material that is flexible and more lightweight. And we found that to be really valuable, and the investigators that we work with really like doing that. In March of 2018, we partnered with the U.S. Food and in March 2020, at the start of the COVID public health emergency, we partnered with the U.S. Food and Drug Administration, the Veterans Healthcare Administration, and America Makes to come together and create a collection of 3D printable designs coming from the open source community that we pulled them together, like face shields and masks and ear savers. And the VA actually went about printing those and kind of giving an assessment on where they might be best applied, say in a community setting, just for a face shield that an individual might wear, or someone in a grocery store or a restaurant, versus something that would have added protection that would be suitable for a clinical and healthcare environment, which we know is really important when we are dealing with this infectious pathogen and wanting to stop the spread from ourselves and others. So that's taken off really well. We have over 600 published designs. We have an amazing community of users that have uploaded and shared what they've done. And we're really excited to see how we can support the open source design and 3D printing and additive manufacturing community moving into the future, which hopefully not a pandemic, but other kinds of emergencies where these kind of devices, the supply chain gap could be supported through additive technologies. I'll also mention that a lot of what we do is supporting our leadership and the investigators and researchers with models that they can use to communicate scientific concepts. And we really jumped on this in January, that we could make models of the SARS-CoV-2 virion and related proteins, which is SARS-CoV-2 causing COVID-19. You'll see here on the left, Dr. Francis Collins, our NIH director, using that to talk about SARS-CoV-2 and COVID-19. And then we've also done a good bit of work with this in our BioVis lab using VR and AR to explore those. So the really exciting part as far as our 3D printing goes for ourselves is that we are renovating our offices to have a new 3D printing lab that we're very excited about, and that should be ready when we are back in the building. And we really want to focus on expanding our 3D printing services to clinicians at the NIH Clinical Center and throughout NIAID. So rather than us just making anatomical models, we can work with them to help them create something custom to work with patients and surgical planning, and all those great applications, how we see the medical community applying those. And then we'll be continuing to do all of the fun R&D with 3D printing and finding new interactive and creative ways to use 3D printing, whether for research or communication purposes, as well as continuing our visualization work and building out the next version of the 3D Print Exchange, NIH 3D. So hopefully we'll have that in a year and you all can go and check that out as well. I'll just give acknowledgements to our leadership and our collaborators. And finally, thank you Formlabs, and thank you everyone for listening. And we hope you'll check out our resources. Thank you.